All right, let's open up Lesson 3 of Module 5 and talk about how OSPF actually decides which path is best. The answer comes down to one simple formula. Cost equals reference bandwidth divided by interface bandwidth. Over the next few minutes, we'll unpack what that means, why the default reference value can cause problems on modern networks, and how to tune it so OSPF makes the right choice. So here's the formula in its cleanest form. Cost equals the reference bandwidth. By default, 100 megabits or 100 million bits per second divided by the bandwidth of the interface itself. OSPF then adds up the cost of every link along a path, and the path with the lowest total wins. One small but important detail. Cost is always rounded down, with a floor of 1, so a link can never have a cost of 0. Let's plug some real numbers into that formula. A 10 megabit Ethernet link gives us a cost of 10 fast Ethernet LANs cleanly at 1, and a T1 serial line works out to 64, which feels about right for a slow link. But look at Gigabit Ethernet. It also rounds down to 1. And a 10 gig link? Still 1. That's the problem we hinted at. Anything fast Ethernet or faster is indistinguishable, which is exactly why we'll need to raise the reference bandwidth. So here's the fix. Under the OSPF process, we use autocost reference bandwidth and bump it up. In this case to 10,000, which is 10 gig. Now a gigabit link gets a cost of 10, and a 10 gig link drops back to 1, so faster links actually win again. One catch though, this value has to match on every router in the area, otherwise the costs you're comparing aren't really comparing the same thing. Once every link has a cost, the actual decision is pretty simple. OSPF walks each possible path to a destination, adds up the outbound costs, and the lowest total wins. So heading to 10330, path A through R2 costs 1 plus 1, that's 2. Path B through R4 is 10 plus 10, 20. Path A goes in the routing table. You can confirm it with show IP route OSPF. And if two paths tie, OSPF will load balance across them, up to 4 by default. And that's the theory locked in. Next up, we take it to the lab. Module 5, Lesson 4, a single area OSPF build where you'll configure it, watch neighbors form, and verify those costs on real interfaces. If this clicked for you, hit like, subscribe, and turn on notifications so you don't miss it. The full course lives free on YouTube and over at Dargslan.com. See you in the lab.